Yeah.
Thank you. Hey, gentlemen, thank you very much. It's my pleasure now to introduce Randy Brudzinski from Microsemi, who, by the way, is going to be providing us with lunch, so we figured we'd give him some time to talk. So, Randy?
Thank you. You bet.
Appreciate everyone's patience. So I haven't even started, but I know I'm already late. That's not the title of the presentation. But we have heard customers say that before to us. Exactly. So Randy Pierzynski, I'm responsible for the frequency and time division of Microsemi. I'm going to give a little bit of an overview of our company, what we do, the customers that we serve, and trends that we're seeing in the industry. So we're a publicly traded company, not on this exchange, but not far from here. Large company, so we are known as a leading semiconductor and system solution company. We focus on power, reliability, security, performance. These are differentiating features of all the solutions that we make. My division, the frequency and time division, is an important part of what we do, serving critical infrastructure, and I'll get into some of the details there. We're a little over 1.8 billion in revenue. We're actually at 40. We just did an acquisition recently in clocks, in quartz oscillators, a Vectron acquisition that happened a couple of months ago. So we're now at over 4,800 employees. And of those 4,800, a little over 10% of our employees are actually focused on synchronization and timing. So we spend a lot of our resources, a lot of R&D investment goes into evolving our solutions and helping the market. So what do we do? Kind of two ways of looking at our business: providing system solutions, where we make the Grandmaster clocks, we make the cesium clocks, we provide the software, we provide synchronization services. We also provide components, so the timing ICs that go inside of networking gear, that go inside of a GPS-DO. We make GPS-DOs as well. We also make solutions that are based in space. So pretty wide portfolio of synchronization and timing solutions that we offer from Microsemi, whether it's us providing the end-to-end solution or providing components to some of the suppliers that you may be aware of. In terms of market share, in terms of what we do, we talk a lot, and here in earlier presentations we talked about traceability to UTC. I've got a little chart on how that works, right? We talk about it a lot, but some folks really don't understand how UTC is derived. I could have spent a lot more time if I had an atomic physicist come in here and give a much better presentation of that, but there's no way an atomic physicist could talk about anything in less than 10 minutes. So I'll do my best to provide the information, the overview there. In terms of market share, we're a leading supplier to several different markets, primarily military, large enterprise, financial markets, and telecom is a very, very large market for us. We make the miniature atomic oscillators. You may have heard of something called a chip-scale atomic clock. We also make the cesium references as well. So here's the architecture of UTC, and in this case, we could be talking about NIST, a similar architecture. In this case here on this chart, we're talking about the USNO. So, really what it is the USNO has an assembly of clocks, lots and lots of clocks. Many or most of them come from us, whether they're the cesium atomic clocks or our hydrogen masers. They're essentially setting the time in the GPS constellation, where there are also clocks based in the satellites themselves. And then, of course, the distribution of time worldwide through that low-power radio frequency to all the GPS timing receivers that are used, in your networks and in critical infrastructure. Of course, we also provide these timing servers in these markets as well. So those of you with cell phones, and I presume that's everyone in the room, and you're operating in the U.S., and if you're on the AT&T or the Verizon or the T-Mobile or the Sprint or some of the other brand name service providers in the U.S., the synchronization that happens within those networks is brought to you by our synchronization products. So you've seen similar charts to this in previous presentations, and folks are very well aware of how important timing is for critical infrastructure, and this is what we do. So we serve these critical infrastructure customers. We talk to them about their challenges. We provide solutions to them. We also provide solutions to their suppliers. So we're pretty deep in the ecosystem of timing and synchronization. Thought I'd share a little bit in this presentation the trends, what we hear. And some of it was, I know you're well aware of, but just from our perspective, what we're hearing from our customers or what we're seeing. Accuracy, right? I think we all can assume that accuracy requirements are going to continue to tighten. Obviously, we're seeing that in the financial markets. It's been happening in telecom. It's happening in power. We see it in the standards bodies, particularly the ITU, with more and more standards that are coming about that have more of a focus on time. Years ago, the telecom network, they talked about stratum levels. They talked about primary reference clocks. Now they're talking about primary reference time clocks. So time has become much, much more relevant in all these different markets. So there's the accuracy, right? So when you're looking at the grandmasters, you're looking at a solution, you need to make sure that you're finding a solution that gives you the best accuracy. The other piece is resiliency, right? So we've been talking in previous presentation, we've been talking about GNSS vulnerability, right? So the jamming, the spoofing. Well, we've been serving our customers and addressing GNSS vulnerability for a long time. It's nothing new, right? So the GPS signal can be interrupted just by physical damage, right? So the previous presentation had pictures of those L1 antennas that look like little mushrooms, right, that are on top of the building. Well, for years, we've been serving customers who had problems because something like ice or snow or, believe it or not, bird dung causing interference with the GNSS signal, right? In rural areas, some folks like to use those as target practice. So we've talked to our service provider customers about ways to mitigate that. And that's primarily in the past been holdover using atomic clocks, whether it's rubidium or cesium. What's new, of course, is the nefarious GNSS interruptions, whether that's jamming or spoofing, and that's something that will continue to evolve now that it has industry focus. Now that we're reading about it and we're hearing about it in mainstream media, the bad folks that are doing this, they're going to continue, just like what's happening in hacking of a communications network or your enterprise network. This is going to continue. We can expect it. And then lastly, and it's really associated with this, is security. How do you protect your network? How do we protect critical infrastructure from these threats? So this is something that we're working on with our customers and also with government entities so that we can bring to market a solution that's going to help all of us. So, this is our sort of the quick product pitch of what we do. We talked about precision and accuracy over here, and I encourage you to stop by our booth and talk to our subject matter experts about providing, very precise source clocks and grandmasters. Then we have the holdover capabilities, so that in the event that you have an interruption to GPS, that you can actually hold over. I think earlier we were talking about, what is the time requirement for that, right? So the time requirement for using cesium is quite a long time. So it's really just a matter of what your application requires. And these are the kinds of things that we can work with you and with your suppliers. So note here, there's a cesium clock. This is the 5071A, which is really the top in the industry. This is what the contributors to UTC use. This is the gold standard cesium reference. But if you're looking for solutions that are scalable, that there's price sensitivity, and you may not need the level of precision and holdover of a large cesium reference clock, we also have the atomic oscillators as well. And then, of course, there's software so that you can continue to monitor what's going on. You can measure to make sure that you're adhering to the regulatory requirements. And then lastly, this is our latest introduction, and we encourage you to come and talk to our product experts about this, and that's the GPS firewall. So what is the firewall? It's analogous to a network firewall, right? So you're protecting your timing network, and what we've done is introduce a technology here that doesn't require critical infrastructure to do forklift replacements of their timing infrastructure. I mean, there are a lot of grandmasters, a lot of GPS receivers worldwide. The cost to replace all of those with something new is staggering. It is staggering. We have a very deep understanding of how those timing receivers are used, how they're wired, how they fit into the infrastructure within critical service providers. And we also know that it's not just the cost of the hardware, it's the interruption of the network to be able to retrofit, okay? And so what we're trying to do is make this easier for critical infrastructure to protect their network. With that, I thank you and encourage you to come meet our experts. Thank you. I'll give it to our experts to answer. Okay, Mark. Hi.
Box you put between the antenna and a GPS receiver, I'm really interested in that. And I was going to go to the booth, but since I had opportunity and nobody was asking, doesn't that have to be a GPS receiver in itself? So that you're actually adding another receiver between the antenna.
So it fits in line between the antenna and your timing receiver.
But it has to do the functions of a receiver in order to do all that detection and mitigation.
So it's constantly monitoring the integrity of the signal, looking for, there are whitelists, there are other mechanisms that we're using to determine whether the signal is a legitimate signal that you should rely upon. And once you deem that it is, and there's two modes, right? So it's deemed reliable, it's deemed legitimate signal, and that passes it on through. If it deems that it's not, then it goes into two modes. It can be a firewall that it just shuts off the signal, and then your timing receivers southbound would end up responding the way they would if there was a GPS outage. So if they have holdover, then they go to their own holdover, right? If they have a rubidium clock or if they have an external cesium reference or something like that, they would operate the way they normally do. If they don't, we provide a synthesized signal that keeps the network happy. And we use that by using external references. And at this point, I'm going to encourage you to come and talk further to our product experts before I get myself into any further trouble. Thanks.